Today's lecture will be talking about the greenhouse effect and global climate change, also called global warming. The purpose of the lecture today is not to convince you of my opinion or get you to believe what I think. It's also not to convince you of a specific opinion. I'm not trying to convince you that global climate change is something to worry about. I'm not trying to convince you that it's not something to worry about. We're just going to talk about the facts today, the things that we can prove with science. So global warming or global climate change is just this idea that temperature as a whole is actually not just changing by the seasons, but it's changing and increasing over time, right? So if you take the average temperature of the Earth and you plot it every year, right, you will get a graph that looks something like this, right, where the temperature goes up and up. Now, keep in mind, we're scientists, we're not politicians, we don't just interpret graphs the way we want and manipulate things. So don't forget on all of these graphs, because a lot of these may have been these graphs that we have gotten that are in books or on the internet or wherever you might find them. Okay, a lot of them you will find will be posted by someone who has an agenda, someone who's trying to convince people of stuff, right? So oftentimes they will manipulate the graphs. Keep in mind, so this graph right here, look at the graph, look at the axes of the graph and make sure you understand. So this is over 130 years of time, and you'll notice that the temperature does rise, and that is true. It has been rising, but notice the temperature difference, right? 0 is supposed to be the temperature that you would expect the Earth to be at. So at first it was colder than what we normally expect the Earth to be at, and then it warmed up more and more and more and more, and the actual temperature changes from negative 0.2 up to, I don't know, negative 0.5 or something. So that's a change in temperature of about 0.7 degrees. That's not very much, right? But it is a change in temperature, and actually a little bit of change actually does cause a difference, and it makes a difference. However, just keep in mind that this looks like a huge increase. It's just 0.7, so always make sure you look at your axes. Now, the average temperatures are currently close to an all-time high for the last 400,000 years. Okay, so we're going to look at how do we even know that? How do we even know the temperature? In fact, at this time we want to discuss what are the possible sources or reasons why this temperature might increase. Okay, so if you want, you can pause and try and guess. Here are some of my ideas of what, and other scientists' ideas of what might be causing this. Okay, one of them, of course, is the most commonly accepted one from a lot of scientists, and that is that the changes in the composition of the greenhouse gases in the atmosphere could be affecting this. So in other words, if we get more greenhouse gases, we'll hold in more energy, and therefore it'll warm up, right? So also other ideas could be that there is an increase in solar flare activity, which is true. It has been increasing. A solar flare is basically like a giant explosion on the surface of the sun, which spews stuff out in the air, or sorry, not out in the air, but out away from the sun. It does come back in, but at the same time, it increases the solar radiation. So it gives it a burst of energy, or shoots out a burst of energy from the sun all at once, and so that means that the actual energy coming off the sun is ever so slightly higher than what it would normally be if there weren't as many solar flares. So it could be that's the reason why the temperature is increasing. It could also be the fact that the Earth's orbit is changing ever so slightly, right? If we ever get a little bit closer to the Earth, if the Earth ever gets a little bit closer to the sun, then that means our intensity will go down because we're getting energy when we're closer, and it'll be a smaller surface area. Okay. Also, it could be even volcanic activity. Right? The Earth also has an internal temperature, and it's really warm in the inside, and so it could warm up the outside by having a lot of volcanic activity and bringing some of that internal heat out. And that is true that we have had an increase in volcanic activity recently. So which one of these reasons is probably accepted by many scientists? And the one that we're going to be focusing on today is the top one, the idea that perhaps it's increasing because the changes in composition of greenhouse gases in the atmosphere. That's the one we're going to be focusing on, but it could be other ones of these, and other scientists will argue one or the other. Okay, so it's not necessarily, we don't know for sure it's this top one, but a lot of scientists believe it's that one. There better be a reason for us believing it, right? Again, we're not politicians. We don't just pick whichever one we like. and we go with that, we're going to pick the one that we have the most reason to believe. So there should be some evidence for us to believe this. So what are some of these reasons why some scientists believe an increase in greenhouse gases is causing the temperature to rise? Well, in order to really know, we actually have to look back in time. We actually have to look and see a trend, and that means that we need to see the percentage of greenhouse gases and compare it to the temperature over a long period of time. It's hard to do that. One of the ways we do that is by looking at ice cores. So what they did is they go to Antarctica and they drill down and they get out this core of ice. So they drill down with this drill and they pull out this core of ice like this girl is holding right here. And this core of ice, similar to a tree, which has different rings around it, has different levels or layers of ice. So just like a tree, right, you can look back hundreds of years, many years in a tree by the rings, and you can see, like, you can tell if there was a drought one year because the ring might be really thin, or if there's a black ring, maybe there was a forest fire one year. And it's kind of like looking back in time by looking at the rings. Similarly, snow falls every year and freezes, right? And when it falls, it gathers information about the atmosphere because it's passing through the atmosphere and gathers some of those chemicals or whatever's in the atmosphere at that time. So if you drill down through the ice, it's like drilling back in time, all these different layers from past years and hundreds of thousands of years ago, and you can look at all of these different layers and you can gather information and you can learn what the gas concentration was during those years. They have done this for hundreds and thousands of years to get the information, and you'll find that information in the following graph. This graph here is an example of the CO2 concentrations found in the atmosphere. Again, don't forget to look at the axes. Notice that this is a skewed graph. It doesn't actually go down to zero like it should. So this looks like it's like the concentration of CO2 is actually almost zero at this point. It's not. They're just trying to make the difference more extreme, okay, by zooming up. Keep in mind that this graph is actually longer and the extremes aren't quite as much, but it's still going up and down. And so from the beginning of time, so 400,000 years ago on the Earth is how far back they're looking at this. Okay, and they've noticed that at different times the CO2 level is really high, and then it goes down, and then it goes up, and then it goes down. And the Earth actually has a natural fluctuation of carbon dioxide. So there are natural causes for why carbon dioxide might increase and decrease and increase and decrease. Okay, this is even before where humans are on the Earth, right? So there's got to be some kind of natural reason for this. As we zoom up on the last 8,000 years or so, though, you'll notice an interesting trend. It stays relatively constant, and if you zoomed up on any part of the other graph, right, even though it went up and down and up and down, this is over hundreds of thousands of years, right? So these changes aren't actually that quick. They're kind of subtle. So when we zoom in, we should see even more subtle changes. Like this is a slow increase, right? A subtle change. But you can see right around the Industrial Revolution, boop, it jumps right up. Okay, and this is around the time when we were building devices that burn fossil fuels. So if we zoom up one more time, just in the last 50 years, right, you can see it go up and up and up even more. This is a very large spike for just 50 years. That's a very, very fast spike, which is very unusual for the rest of the time. Okay, it usually never jumps up quite that fast. You can see similar trends with methane gas. Okay, and again, near the end, you see this giant spike of methane gas. Again, zooming up. Okay, however, why does this mean that this might be causing temperature change? Just because there's fluctuations in CO2, that doesn't necessarily, or other greenhouse gases, that doesn't necessarily guarantee that that's the thing causing a temperature change. So why would we think that it's causing a temperature change? Well, the reason is because when you look at two graphs at the same time, you start to see an interesting trend. So up above is the CO2 graph, right? It goes up and down. This is the one we've already seen. And then down below is the temperature one. And if you look, there's a very interesting correlation. Each time the CO2 is high, the temperature is high. Each time the CO2 is down, the temperature is down, right? Sometimes one falls before the other, right? They're not perfect correlations together, but there is a large correlation in general, a large general correlation. So every time spike, spike, low spike, low spike, 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 right? spikes, 2 spikes, and then 2 spikes, right? And then it goes down, and then this goes down. And there is a large correlation between the temperature and the CO2 levels. So that's interesting. We can't prove that that's what's causing it. This isn't proof. But what this is this is showing a large correlation. And so it makes us worry that when one goes up, that means the other one's going up. And since at the last couple of years, we have seen this giant spike on the CO2, right? Remember, in the last couple of years, we've seen this giant spike. Then we're worried that the temperature, right, will also spike. That's the worry. Will it? Oh, I don't know, but we're worried that it will. So as we see this giant spike, that's what we become worried about. Now the question is the next question is, what is causing that CO2 to spike? So there could be different reasons to explain why these other CO2 and other greenhouse gases are increasing. The most common belief is simply that we're burning a lot of fossil fuels. And probably the reason why we're believing this the most is because, again, remember that spike just happened to start right around the Industrial Revolution. And so it's rather coincidental, I think, to have this giant spike right at the time when you're burning a lot of fossil fuels, which we already know give off a lot of CO2 and other greenhouse gases. So it is it's kind of just the simplest explanation of what might be happening, since it just happens to correlate around that time. However, it's not the only one. So other possible causes for the increase in greenhouse gases include the following. Number one, there could be increased volcanic activity. The Earth stores a lot of CO2. Excuse me, the Earth stores a lot of CO2, and during volcanic activity brings a lot of that CO2 out of the ground and into the air. Also, an increase in forest fires. Naturally, forest fires occur all the time because of lightning strikes and things like that. However, with humans, right, we end up creating occasionally more forest fires than we intend, more forest fires than if it was just nature, I meant. And so forest fires, in addition to causing deforestation, when the trees are trying to get rid of some of that CO2, the forest fires themselves is burning a lot of biofuel, which creates a lot of CO2 as well, kind of like burning fossil fuels. There are other natural processes as well. I mean, there's other things like just the fact that we have greater population, right? We all exhale and we all breathe out CO2. In addition to that, we all require food. So we have more cattle on the earth now. We have more people on the earth now today than probably the first 5,000 years of the human race, all put together. If you added everybody who lived in the first 5,000 years of the human race, we have more people on the earth now than we did back then. So there's a lot of more people. Now, in addition to needing more food, we also, and more cattle, we also need more space, which means more deforestation and things like that. Okay, in addition to this problem, we're also worried about some things that will accelerate the problem. So though the amount of increase in temperature for the last 130 years is only about 0.7 degrees of Celsius, that's not a huge change, but it's large compared to some other changes we've seen. But it's not that big. So the question is why are we so worried? Well, one of the things we're worried about is that as it warms up, things will kick in, processes will kick in that will actually accelerate the warming process. For example, as the earth warms, the ice melts, right? And remember, ice helps provide the albedo. The more ice there is, it's white, right? And the earth will then reflect more. So by warming up and melting some ice, you lower your albedo, which means you're absorbing more energy, which means you'll melt even more ice at a faster rate, right? And so it just, one thing causes another and speeds up the process. Okay, other things is that there is more evaporation of water. And remember, water vapor was one of those greenhouse gases, right? So the hotter it is, the quicker the rate the water will evaporate, which means we get even more water vapor, which means we'll warm up even faster. Other things also include, right, that the temperature decreases the solubility of CO2 in the sea. Just like the earth, the water actually holds a lot of CO2. Okay, it just holds it in the water. And things like phytoplankton will absorb that and use that for photosynthesis and create oxygen as well, similar to other plants. So while the sea holds a lot of that CO2, as the temperature increases, it can't hold as much. The solubility of CO2 goes down, so it can't hold as much, and so therefore it has to release it. So increasing the temperature might release more CO2 from the water, which would just cause more of a problem, and if it really is the CO2 that's causing it to warm up, right? And then it would cause more of a problem, and it would just get faster and faster, warm up quicker and quicker. Some kind of doomsday scenarios of what might happen are as follows, and you should be aware of some of these scenarios. So number one, the average temperature they've modeled that it might raise by 2 to 4 degrees by the end of the next century. So in other words, in about another 100 years or so, it'll increase 2 to 4 degrees. Now notice, in the last 130 years, it only increased about 0.7 degrees Celsius. So the only reason why they might think it might increase another 2 to 4 degrees is because of these accelerating factors. So it's really hard to predict everything that's going to happen because the Earth is a very complex system. So keep in mind that all of these are guesses and predictions, and by using models of things we do know, but we may not have included everything that could happen, right? So a lot of these are our guesses. Other problems might also include having the sea levels rise, and they could raise up to 20 to 60 centimeters. Now, that's actually not a whole lot of height to raise your water. However, you don't need a whole lot of height to cause some serious problems. Number one, a lot of our major cities in the world are all found really close to water, okay, and really on flat spots too. So even just raising 20 centimeters would cause a lot of these cities to be underwater. Now, when I say underwater, I don't mean skyscrapers underwater. I mean there's like a thin, 2 inches of water everywhere. Now, the problem with that is I don't care where you are. You cannot live when there's like 2 inches of water everywhere. Okay, you can't live in a lake where there's 2 inches of water. That water will cause damage in your homes. You won't be able to live there. It'll cause mold. It'll cause, malaria because mosquitoes will come in and breed and et cetera, and it just causes problems. You can't live on water. I don't care how big it is. You still can't live on it. So that would cause massive problems where people have to move, and entire cities are basically destroyed just by a little bit of water. Other problems are severe storms. Storms are caused by the rapid change of temperature from hot to cold or cold to hot. This is why there's more storms in fall and winter than in summer and sorry, I said fall and winter. I meant fall and spring rather than summer and winter. So right as these temperatures change, it will cause more severe storms. Also, we could even enter a new ice age. The reason is because as the ice caps melt and some of that cold water goes into the ocean, we have water currents that go from warm places in the water to cold places in the water. And what that does is it actually acts as a conveyor belt of heat. It takes warm water, right, and moves it up to cold areas and actually keeps cold areas slightly warmer than what it should be without these currents. And if the ice melts, right, it'll cool down some water in certain areas, and it would basically disrupt these currents, and it could theoretically shut down the currents. And if the currents shut down, what that means is heat will stop flowing up to the top, and so near the top of the Earth, where it's cold, will become even more cold, right? So while the Earth is heating up as a whole, right, so the equator is getting hot, the top, if it shuts down these currents, could actually make it really, really cold, and so the ice would start to then cover a lot more of the Earth. And it would just be the polar ice caps would just be huge instead. So this is another possibility of what could happen on long terms. Also, water can be more acidic, which can kill life. You can destroy ecosystems. There have been recorded incidences where, for example, I can't remember the name of the bird. I need to look it up. There's a type of bird that is endangered. It's because it usually feeds off of a certain insect, and these insects usually hatch at a very specific time. However, because the Earth has increased just a little bit in temperature, so again, last 100 so years, the temperature has just increased 0.7 degrees on average, right? However, as it increases just a little bit, these certain insects that the birds feed off of always hatch at a certain time of the year, because it's always a certain temperature, and now they're hatching just 2 weeks early. That's it, just 2 weeks early. And as a result, these insects hatch, they breed, they die, and then the birds come in to feed, but the insects have already hatched and are gone. So then they're in trouble, and it can disrupt different ecosystems, and we're even seeing that now. So there are too many factors to really accurately predict. Keep in mind that these are just scenarios, possible outcomes that we're guessing and trying to model with the physics and science that we do know. Okay, we talked about the sea level rising, and there's one thing that you need to know that's important is that it's not because of melting icebergs that will cause the sea level to rise. For example, in this picture right here, we have ice in a cup. The water is at the very tippy top. If this ice melts, water will not overflow. And the reason is because when water freezes, it expands, right? So as it melts, it will take up less space, and it'll all fit in the glass in the end. This water is already floating, this ice is already floating. It's not going to raise the water level. However, the ice that will raise the water level is ice found on land. So here's a picture of Greenland, right? And all this ice that's on the land, that's the stuff that we have to worry about. And you can see there's the ice in 1992. Here's the ice in 2002. And it is definitely a heck of a lot less ice. So this ice is melting and then going into the river or into the ocean. So keep in mind, melting floating ice does not change sea level. Keep in mind that it's only the stuff on land. Also, other things you should know is that as the temperature gets bigger, the other reason why the water level will be higher will actually be because the water in general will just simply expand. Anything that gets warm will expand. Here's a picture of a railroad track that on a very, very hot day where it has expanded to the point where it has just basically warped and just destroyed this train track. Okay, nowadays they actually put gaps in the train tracks so that there's room for the tracks to expand and then contract throughout different temperatures. So all things expand when they get hot, including water. Here's an equation you could use. You do not need this. I haven't ever seen an equation or anybody use this equation, but you at least need to know the general idea that the water does expand, and that's one of the other reasons why water level will increase. So what are some solutions? What could we do to help solve the problem? So there are different things we can do. Number one, there's different technological solutions we could use. Number one, we can make more efficient use of power, right? So anytime we use power, we could make devices that use it more efficiently. So more efficient, high efficiency washing machines and high efficiency laundry machines and high efficiency refrigerators, and you bet anything that will use less energy, because we have to often create that energy, often using fossil fuels, right? So by using less energy, we're burning less fossil fuels. Other things we could do is we could try and decarbonize exhaust, like from cars and stuff. That means somehow capture that exhaust and by some chemical process just capture the CO2 in the exhaust and store it somewhere, right? I'm not exactly sure how that would work, but you could do something like that. That's one of the things they're trying to look into. Also, other things is instead of just trying to solve it with technology, you can just try and reduce the energy requirements that you have, right? So kind of like more efficient instruments. You can try and do things like don't waste the energy as much, or by thermally insulating your home more, right? That way you'll require less energy. You can reduce the amount of travel you do, or somehow use more efficient modes of transportation. Take the bus, right? So more people are taking this or going on the bus, and so there's less gas burnt. You could use also systems that combine heating and power, right? So an example of that would be solar heating, right? So and you can also use it to make electricity as well. Things that combine both systems, and one, you save some energy. And then the last couple of things would be to replace coal and oil sources of energy with renewable energy sources that don't create CO2. And you can plant a couple of trees, right, which would also help and a little bit to reduce CO2. Some of the worldwide efforts I don't know anything about.